Okay, today I'm going to make some videos about the mathematics Form 4. I think it's chapter 11. This is the video called lines and plans in three dimensions. Okay, for me this video is quite difficult to make because it involves three dimensions. When three dimensions, for me, it's quite difficult to explain in the videos. However, because few students asked me to make one videos to say about this, so I just do my best to make the student understand about this chapter. Okay, first, okay, before I start to bring in all the example, okay, in this chapter you have to understand a concept which I think is quite important if you want to fully understand about this chapter. Okay, which is I call it shadow line. Okay, for example, you will see a paper over here, and then you will see a line actually is standing. So it's actually like something, you see a paper over here, and then you will see a line standing like this. Okay, so when the line standing like this, okay, so this is the line, this is the line actually standing on the paper. Okay, imagine this line actually standing on the paper, something like this. Okay, if this is the line, okay, what happened now is, okay, imagine this is a piece of paper, okay, in 2D, and then this is a line actually standing. Imagine you will have a light over here. Okay, the light is from the top to give the light to this standing line. Okay, to this standing line. So what will happen? Actually, he will form a shadow over here. So actually, he will form a shadow over here. Do you see? If the light from the top, actually he will form a shadow over here. Okay, this shadow is very important. Means what? Means actually, if this is a paper, okay, this is the line standing, and then got light from the top. From the top, you will see actually you will have a shadow over here. Correct or not? Okay, this shadow, I call it shadow line. However, he got his own term, which they call it orthogonal projections. This shadow have a name. They call it orthogonal projection. If you can understand this line, he can help you solve almost 50% of the questions. Okay, of course, if you can only see the shadow over here, or they call orthogonal projection, you must also will see a normal line, which is from this line you will form a 90 degree to the shadow. You will form a 90 degree to the shadow. This one they call it normal line. Okay, means what? Means this is the plan, and then you got a line over here, and if he asks you to find the angle between this line and this plan, you must able to see the shadow over there. Then you can know this is the angle on between. This is the angle on between. Okay, this is the angle on between. Okay, this concept is very important, so let me explain one more time. So you got a 2D plan over here, and then you have a line standing. Imagine this line is standing, and then the light from the top, he can form a shadow, or they call orthogonal projections on the plans of this 2D plan over here. And then you must imagine this normal line yourself. Normal line means what? Actually, this line will form a 90 degree triangle. Means this line is 90 degree from this plan. From this plan is 90 degree from this plan. This one we call normal line. Okay, normal line means if this is a plan of paper, this line will stand 90 degree. Means you will form a 90 degree over here lah. Okay, I hope you can imagine before I go further. Okay, if you can understand this one, then yes, then it will be very good for me to continue my next question. Okay, so I just choose some simple past year question first. Okay, first, this is one of the past year question. You will see a cuboid over here. Okay, and then he will give you some information. The line AM, okay, line AM is 15 centimeter, and M is the midpoint of EH. Mean M is the midpoint of EH. Mean these two is the same length. Okay, this one and this one is the same length. Okay, it doesn't matter. Okay, now he asks you find the angle between the line AM and the plane ADEF. Okay, in order to find the angle between first information is you must find where is the ADEF first. So, okay, let me use green color. Okay, where is ADEF? ADEF is this plane behind. Do you see this one is ADEF? Okay, now we got this ADEF, and then we got the line AM. Okay, if the plane is over here, your lighting cannot from top. If you're lighting from top, you cannot see any shadow, or they call it orthogonal projection, on the plane ADF. So in order to see the shadow of the line AM, your light must from this direction. Means must from this direction. Okay, if from this direction, okay, you imagine this is 3D, actually it's from this direction. It's from this direction. Okay, from this direction. Okay, if from this direction you see the line AM, do you see it actually will have a shadow, or they call orthogonal projection over here? Do you see this line? Or maybe I use some darker color. Okay, if the light is from this direction, because this is the plane, so the light, in order to form a shadow for the line AM, the light must from this direction. Do you see actually you will have a shadow over here? Do you see actually this one is a shadow of this line on this plane ADEF? Okay, if you can see this shadow, then will be very good. Means you actually can see another, they call it normal line over here, and then he will form a 90 degree. He will form a 90 degree. So actually you will have a right triangle over here. So I say you must understand this concept is very important. So if the plane is on the bottom, so your light have to on the top. If the plane is like this, your light have to be like from this direction. If your plane is on here and then a line is like this, then you should be from this direction. So have to depend where is your plane, then you can determine where should you put your light to imagine that shadow. If the plane is on the top, the light should from the bottom. Okay, so this one plane is on the bottom, so the light is on the top. Okay, so from this one you see the plane is actually on the side, so your lighting should from this direction in order to see the shadows of AM. Okay, if you able to imagine out this shadow, which is the AE, then you can form a normal line, and then the normal line from M to E to form a 90 degree. I say normal lines mean actually it's a straight line, and then we'll give you a 90 degree over here. Then you will see a triangle. It's a right triangle. This is a right triangle, AME. Okay, then if you can see this one, then it's pretty simple for you to solve this question. If you can see, okay, so now I want to draw out this triangle. So when I draw out this triangle, I draw the EA first, AE first on the bottom. Okay. This is E, this is A. Okay, EA, and then E will connect to M, form a 90 degree. So E will connect to M, form 90 degree, and then M will connect to A. M will connect to A. Then you will have a triangle like this, and then you will have some information as well, which is this one is the midpoint one. The straight line over here is 8 centimeter. So half means here is 4 centimeter. Means actually here is 4 cm. And then it tells us the line AM actually is 15 cm. So from here, where is the angle on between? So obviously, the angle on between is this one. This over here will be the angle on between. Means between the line and the plane. Means is this angle. This is the angle on between. So will be here. So you got opposite and hypotenuse. Obviously you can use size. Okay, you got opposite and hypotenuse. You can use size. Size is equal to opposite over hypotenuse. Okay, this is trigonometric. So I hope everyone can understand. Then you find the angle. You just press your calculator, shift sign 4 over 15. Then you can got the angle. Okay, let me take my calculator. Okay, so now I press shift sign, bracket 4 over 15. Yes, so I will got the angle is 15.47. Okay, this is the angle 15.47. Okay, so this is the between the line, and then you see a shadow, and then for a normal line, and then you will see a triangle, and then this one is the angle on between. Okay, okay. In order to make you understand better, so actually I take another 2 more examples for line, and then we see, and then we will go for the plane and plane. Okay, this one is the line and plane. Okay, okay. So we go to the second one. Okay, for this one. Okay, for this one. Okay, let me change another paper, make it clear. Okay, you will see a prism over here. Okay, so now he asks you calculate the angle between the line RU. Okay, you will see a line RU over here. Okay, immediately a straight line because I draw from hand, so it's not so straight, but then it's another matter. And the base PQRS. Okay, base is very important. I say base is very important, so I'm going to draw a green line for the base. Okay, PQRS. Where is PQRS? PQRS. So it's the bottom one, PQRS. So let me draw this one on the PQRS. Okay. Okay, now you got the PQRS. Okay. Now the plane is actually on the bottom. This line is standing like this. So where your light should come from? Your light should, if the plane is on the bottom, your light should come from the top. Correct or not? If your light comes from the top, you should be able to see a shadow. Where will be the shadow? Okay, if the plane on the bottom, means your light should come from the top. If the plane is, means your light should come from the top. And then this is the RU. So actually you will have a shadow over here. So you will actually see a shadow. Okay, from the top, you will always see you will actually see the shadow is somewhere here. Do you see? Actually, you will see a shadow is P to R. Okay, it's from P to R. Okay, do you see this shadow? Mean actually your light is from top. For this line RU, actually you will see a shadow from P to R. This one actually is a shadow, or they call it orthogonal projection. Mean actually the light project from the top, and then you will have the orthogonal projection on the bottom. Or okay, I use shadow is much more easy for students to understand. Okay, so this one actually is something like you have a plan. Okay, let me take some paper. Okay, you have a plan over here, and then I got a straight line over here. Okay, so now if the light from the top, I will have the shadow. Do you see a shadow? I will have the shadow over here. Okay, if my paper is like this, okay, this one is standing like this, so I have a shadow like over here. Okay, I think see from this example is actually quite obvious, right? Okay, I hope you can see now. Okay, so this is the straight line, so you have a shadow over here. Okay, so and then of course you have to draw a normal line, means which is 90 degree from the bottom one, so the normal line will be over here. Correct or not? You have a normal line and then you will see a triangle. This one is you have a 90 degree over here. Okay, so if I draw out the triangle, okay, PU, okay, I have, okay, this one is PU, and then I got this shadow line. Shadow line actually is a straight line, because it's on the base. P to R, okay, PR, and then I will go U to R. Okay, obviously the angle on between is over here. This is the angle on between, so it's over here. Okay, I hope you can understand. Okay, and then I will have some information. Because this is rectangle, this is 15, 13, so this line over here will be 13. This is 5, this is 12, so over here will be 13. This is Pythagoreans, okay? Or you do not know how to get PR, you can just use 5 square plus 12 square and then square root the whole thing, you will got 13 cm. Okay, and then the R for the UP, you will got 9 cm. Okay, so it's very simple to find the angle. You got opposite and adjacent. If angle over here, you got opposite and adjacent. Obviously, you use tangent. Angle is equal to 9 over 13. Of course, you want to find the angle, you just press shift tangent, bracket 9 over 13. Then you got the angle actually is 34.7. 34.7. Okay, so I say the concept of the shadow and the light from is very important. So you got the plan on the bottom, and then your light, your line actually is standing like this. So your light should from the top. Okay, okay. So if okay, we go one more before we go to the plan and plan. Okay, for this one. Okay, for this one. Okay, this one is prism also. Okay, okay. Obviously, V is the midpoint of PS. Okay, and then this is a right triangle. This is a right triangle also. So this one is a rectangle. You got a right triangle here. You got one rectangle, one. Okay, you got few rectangle over here. Okay, it doesn't matter. Okay, now I say in order to find the angle in between, first you have to see the question, line UV, this is UV, obvious, and the plane RSTU. Where is RSTU? RSTU is over here, so I use the green color line to draw a RSTU over here. RSTU. Okay. Now RSTU is a plane behind, okay, it's a plane behind. Okay, now you got a line like this. Okay, so now where your light should come from? In order to see the shadow of this line. Okay, it's not from the top, because if from the top you will see the shadow at here. If the light is on the top, you will see the shadows over here. So, but then we want the shadows on the plane. So, obviously, if you ask me, of course I know the light should come from this direction in order to see the shadow. Okay, if the light is come from this direction, obviously you can see the shadow actually is somewhere over here. Okay, you got the shadow over here. Do you see that? It's the light from this direction. For this line, actually you will see the shadow on the bottom. Okay, if you see the shadow, it's very easy. Then you can connect one, we call it normal line. You can connect the normal line over here, and then you will see a 90 degree. I say when connect to a normal line, you will see a 90 degree, and then I can sketch out the triangle to show you. Okay, so okay, this is the bottom. This is actually a straight line. Okay, we draw the normal line first. This one is S to V, so I draw S to V. Okay, and then I draw the PU. Sorry, I draw the SU. SU is the, yes, it's an adjacent line. SU, and then V to U. V to U, just connect lah. Okay, this is 90 degree. Okay, do you see this? Okay, you can flip over if you cannot see this. Okay, so this one is the V. Okay, so obviously where is the angle in between? It's over here. Or they can call it SUV. So this is the angle in between. Okay, okay, this one actually you can call it SUV or VUS. It's the same. Okay, this one I just explain a bit. Okay, for the angle VQS is actually same with the angle SUV. As long as your U is on the middle, then they will know actually this one is the angle. Okay, okay, SUV and VUS actually is the same. Then because they always take the angle values on the middle, which is U. U is over here. Okay, then you just need to solve it. Solve it is, I think it's quite simple. So yeah, you just need some information. Okay, so okay, because V is the midpoint, this is 16 centimeter. So midpoint, I know this one actually is the 8 cm. Over here is 8 what? So here is 8 cm. And then yes, and then I think we can, yeah, this is 12, this is 5, because he says here is 12 what? So here, over here is 12. 5, so this one is 13. So this is 1, 3. So obviously we got opposite and hypotenuse, we can use size. So this one just solve it using the sign. Then you will got, if using the sign, then you will got actually size angle will equal to opposite over hypotenuse. Opposite is 8, hypotenuse is 13. Then angle will equal to shift sign, bracket 8 over 13. You just press the calculator. Okay, shift sign, bracket 8 over 13. Then you got, okay, it's 38. You got angle is 38. So, okay, after these 3 examples, I really hope you can understand how to find the shadow line, and then how to decide where your light should come from. And then after you got the shadow line, you must know how to connect the normal line, which will form a 90 degree and form a right triangle. And then you must be able to draw out the right triangle in order to get the 3 or 4 mark in paper 2. Normally paper 1 is very simple. Okay, okay. After this done, then we go to something they consider, some students will think more complicated. Okay, okay, that one maybe is not so related to the shadow line. However, okay, I just do my best to make you understand. Okay. First, we go to the cuboid first. Okay. This one is what they call cuboids. Okay. Yeah, just let me arrange. Okay. Now, this one you got 2 plane. One is they call it plane BCJ. Another one is they call it, okay, we don't go for this one first. Sorry, we go for this one first. Okay, because this one actually you got some sort like formula. Okay, we're just going to teach you this formula. Actually, this formula you can find it on a lot of reference book. They will say that, okay, when you got 2 plane, okay, when you got 2 plane, which is plane RTU and the plane PQTU. Where is PQTU? PQTU is the behind one. Okay, it's the behind one. So maybe I just draw this PQTU. Okay, this is the plane PQTU. It's the behind one. Okay, okay. When normally when you have two plane, which is PQTU and this triangle plane, okay, the angle is always on the side which is the two plane is connected. Means what? Means if you got one plane and two plane, you got one plane, two plane, the angle is always on between. Means it's on between, it's always on between here. Okay, can you understand? If you got one plane, two plane, the angle always on between. Means the angle is over here lah. Okay? Okay. For this one, you got a formula. This formula can use on the most of the cases for two plane one. Unless the plane is involved midpoint, then you cannot use. Okay? Unless the plane is involved midpoint, then you cannot use this formula. Okay, this formula is like this, very simple. I just hope you listen carefully, or you want to mark down, okay, whatever you like. Okay, you just write down two plane that request, which is P, Q, T, U and R, T, U. Okay, this is the two plane the question asked for. Okay, then your first step is you cancel out, they both have the common one. Okay, P, Q, T, U and R, T, U both also have T and U one. Both also have T and U, so I just cancel T and U for both. When I cancel T and U for both, the three letter one means the triangle. Three letter one, you will still left one letter over here, which is R. Then you find the first alphabet for the angle. First alphabet is R. Mean after you got a three letter here, correct now? After you cancel their common one, which is T and U, you still left an R. Okay? Okay. After you left a R, then you have to fill up the second alphabet. Okay, the second alphabet is from your cancel T and U. From your cancel T and U over here, you have to find which one, okay, which one is nearer to R. Is nearer to R. Okay, T and U, which one is nearer to R? From this diagram. From this diagram, T and U, which one is nearer to R? Okay, if you have some common sense, actually it's quite obvious one. T is nearest to R because U actually from another side what? It's from another side go down. Okay, so it's something like this. Maybe I can show you going. Okay, you got something like here. Okay, this is R right? This is R. This is T. This is U. Obviously, T is nearer to R compared to U. U is more far to R. Okay, means if this is triangle, this one is adjacent, this is hypotenuse one. Obviously, hypotenuse is the longest one. So the second spaces I feel is T because from the cancel one, T and U, T is nearest to R. Okay, and then last step, from this 4 digit, you already cancel 2 what? You still got 2 digit you haven't cancelled, which is P and Q. P and Q, which one is nearer to R? P and Q, which one is nearer to R? So you have to look here, P and Q. Which one is nearer to R? So will be Q. So the last spaces you fill up the Q. This is the angle on between. This is the angle on between. Okay? This formula, okay, let me repeat one more time. Okay, first is you write down 2 plan, which is PQTU and RTU. After you write down 2 plan, okay, you find both also, you find the alphabet, both also have one, which is T and U, then you cancel. Okay, you cancel this one, 3 digit one, you definitely will left one digit, which is R. 1 digit, blah. You will left 1 alphabet, which is R. And then you from your cancel one, you got two alphabet, you already cancel one. You find which one is nearer to the R, which is the first alphabet. Okay, T is nearer to R. And then for 2 alphabet you haven't cancelled one, which is P and Q, you have to find which one is nearer to R. which is the first alphabet you write over here. Both also have to nearer to R. T have to nearer to R, and Q is the nearer to R. Okay, then you can get the angle on between. Okay, this method you can go and open your books or your exercise book or your reference book. You can try in the most of the example. You can use this method. Okay, unless it involve midpoint, then you cannot use this method. Okay, so where is the angle on between? Where is R, T, Q? Where is R, T, and Q? Okay, if from this method you can understand, then will be very good. Then after that, what he asks you to do, he asks you to calculate the angle on between. So what you need to do is, you just need to draw out this triangle, T, Q, and R. T, Q, and R. From here we know the angle is on T. Angle always on between what? R, T, Q, R, T, Q. So you must have some information, which is the length for TQ is 18 centimeter, and then the length over here is 12. So obviously you got opposite and adjacent. You can use tangent. Tangent angle equal to opposite over adjacent, and then to solve it, you just press calculator, shift tangent, and then shift tangent, and then 12 over 18. Yeah, you got the angle is 33.69 angle, or you can say 33.7. Okay, so I hope this some sort like formula can make you understand better. However, from here, actually I will teach you another method. Okay, this method, not to say teach, you have to understand yourself. Okay, in order to draw out this triangle, you must understand. Okay, now this is the plan they asked for. Okay, this is the plan they asked for. I said angle always fall on the between two plane. Between two plane is over here already. So now you have to decide whether you want to draw a triangle for RUP or RTQ. Okay, so this is the difficult part. Most of the students cannot understand. They might draw a triangle for R, U, and P. But then you have to think it in logics. How can you draw a triangle for R, U, and P? Because R and U actually they are crossover. R and U. Okay, do you see R and U? R to U actually they cross over, and then P is over here. So R, U, and P, actually you cannot draw a triangle for it. What? Because it's crossover. This one is different with R, T, and Q. Because R, T, and Q, they are actually all on the same line. You can draw a triangle for this side. If you add a plan over here, actually you can draw. Okay, do you see the difference between? So whenever the triangle plan, you have this the line which is crossover one from one side to the other side, you cannot use this line. Mean you cannot use R to U, because R to U is crossover what? From R cross to U. Okay, and then normally I do this kind of question. Sometimes the question will draw until very hard for me to see the angle on between. Sometimes this one is the triangle plan. What? I will add myself to make it seems like the rectangle plan. So normally I will add up myself to make it look like a rectangle plan. Then it's very easy for me to see the plan actually is the angle actually is on the middle. It's on the middle for two. Okay, means I actually this one is a rectangle. Means actually I add up. Means actually I add up another. I add up another triangle plan to make it look like the rectangle plan. Then it's easy for me to see the angle on between. Okay. Then I hope can make you understand better, because actually it's quite hard to tell you what is this. Okay, so let me let me show you the last example before I end this video. Okay, the last example is what I say you cannot use when you involve midpoint. Do you see this? He said J is the midpoint. Then this plan actually got one of the corner he will touch at the midpoint. Then you cannot use this method. When you involve midpoint, you cannot use this method. So you cannot use this method. How can you solve this question? Okay, so yes, so let me show you this one. Okay, first we have to find where is the two plan. Okay, so obviously I draw one for you, which is B, C, J. Another one is A, B, C, D. A, B, C, D meaning that one is on the bottom. Okay, you got A, B, C, D on the bottom. Okay, now he asks you to find the angle on between. Here he tell you J actually is the midpoint of AF. Okay, now bottom got one plan and the you got another triangle plan. I say the angle will fall on the connection for two plan. The connection for two plan obviously is BC, so the angle will fall over here. Okay, now you have to decide whether you want to take JBA or JCD, or some students might think is JCA. Okay, so obviously the angle on between is over here. Correct or not? This one, do you see the angle on between? Yes. So in order to draw out the right triangle, yes, I say you do not take the line which is crossed from one side to the other side. Do you see? Actually, J to C is crossed from here to another side, here to another side. Yeah, means you do not take this line. So we take the nearest one. Okay, which is JBA. This is angle on between. The angle on between is, so I draw out the triangle, which is J, B, and A. This is angle on between. Okay, because some students might confuse that actually they might argue that actually they can draw J, C, and A. What do you see? J, C, A actually is another triangle. What? J, C, and A. But then this one will give you the different answer. So because okay, let me show this one again. Okay, you got something like this. This is the plan on the bottom. This is the triangle plan. So normally we take the right triangle. We take from the nearest one, the line which is the nearer one. We do not take the line which is crossed over to another side. So we just take the nearer one, which is J, B, and A. Okay, yeah, I hope it's okay for you. Okay, then after you take, he said here is 8 centimeters, so 8 centimeters, J is the midpoint, so obviously here is 4. Okay, and then yes, and then I think this one he just asks you to name the angle. Angle is J, B, and A, or you can say A, B, or J. Okay, I think yeah, J, B, or A, or you can say A, B, J. Okay, and then he will give you some information over here. This one is 6 centimeter. So if this one is 6 centimeter, it doesn't help me to find. I forget to write. Actually, he can tell us here is 10 centimeter. Yeah, here is 10 cm. Yeah, then we can use tangent. Okay, so tangent angle equal to opposite divided by adjacent. So which is you press shift tangent 4/5, 4/10. So you just press shift tangent bracket 4/10. Yeah, you got the angle on between is 21.8. Okay, yeah. I just hope I just hope this video can make you understand better. Okay, if you got any question or you still cannot understand, you please post a comment on my YouTube or on my Facebook page. Then I trying to use another methods to make you understand better. Yeah, this is a very long video. Hope you enjoy watching this video. Thanks for watching.